In section 8.3, here's what we'll do. In section 8.3, we will solve equations for theta, where theta is between 0 degrees and 360 degrees, or degrees, not digress, degrees, or, between 0 radians and 2 pi radians. So that's the heart of this section. We will solve equations for theta. And you just have to make sure that your angle theta is between 0 degrees and 2 pi, 0 radians and 2 pi radians. All right, so it has to be here. It has to live between 0 and 2 pi. And if you look at the unit circle, that's perfect because 0 to 2 pi means within this window. So the answers could be things like pi over 6 or 4 pi over 3, or basically angles that you see here on this map. So why don't we begin? And let's do a handful of equations. And this will be a good sort of summary of what we did last time in class. So example A. And the goal here is to solve for theta. So let's say something like sine of theta equals negative square root 3 over 2. And we begin by recalling that sine is basically the y-coordinate. And what we want the y-coordinate to be is this number here. So I want you to look at the unit circle. And where along this map, where do you see a y-coordinate that says negative square root 3 over 2? So here in green, I see that happening, let's see, right here. And also right there. So these two locations work because the y-coordinate is this number. I see that there, and I see that there. So I give them the angle in radians, 4 pi thirds and 5 pi thirds. So final answer, theta would equal 4 pi over 3, and just put like a comma to separate your answers. Done, 100%. That's what this section 8.3 is all about. Solving equations for theta. So let me erase some of these markings here, and let's now do example B. How about we go like, let's say, how about we go 2 cosine of theta plus 1 equals 0. So I'll give you a chance to jot that down. And we're trying to solve for theta. So maybe first we can subtract the 1 to the other side. So we have 2 cosine theta. So the 1 would be negative. Now let's get rid of the 2 by using division. So these are gone. So we have cosine theta equals a negative 1/2. We then recall that cosine is interpreted as the x-coordinate. And what we want is for the x-coordinate to be this number right there. So where on the map do you see x-coordinates of negative 1/2? Well, we see that happening right there in blue, and also right there in blue. That works there in both those spots. So our angle theta, our theta would have to be, let's say, 2 pi thirds and 4 pi thirds. Done. That'd be your solution set there. That would be your 2 answers. So sometimes you have 2 answers. Sometimes you have 1 answer. Sometimes you have no answers. And sometimes you have more than 2 answers. So let's do a couple more. Let's go example C. What if you have a cotangent of theta, let's say -1 equals 0. Let's add the 1 to the other side. So that cotangent of theta equals +1. And then we recall that cotangent could be looked at as being the x coordinate divided by the y coordinate. So looking at your map, where does this work? Where can I go so that x divided by y equals 1? Well, think about it like this. If you have a number divided by another number, but the answer is 1, that means that the two numbers that you used were probably the same number, right? Like it's the same number. Because if you divide two numbers that are the same, you're probably going to get 1. So where does that happen on the map? I see that here because the coordinates are identical. And I see that across right there. And I think that's the only spots that work. Because someone might say by accident here in the bottom right, but no, because if you divide those, you get -1 because this one's negative. So that one doesn't work. So only these two purples work. And that'd be pi over 4 and 5 pi over 4. So we go pi over 4 and we go 5 pi over 4. Done, 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 done. Final answers. So how about we do one more? And how about we make this one a little unique? This is going to be a little different. A little different for this one, for example D. So let's go example D here. And how about we go like, let's go negative sine of negative theta. And let's go plus cosine of negative theta. And let's say that this equals 0. Yeah, this is a good problem to finish on. So let's take care of this problem here. So I do want to remind you from the previous sections that sine of negative theta can be replaced by negative sine of positive theta. These are facts. And these are just cold hard facts. Also, cosine of negative theta could be simply replaced by cosine of positive theta. And so up here, this would get replaced just by cosine, by substitution, right, based on these facts. Up here, however, this part alone in green, that would get replaced by negative sine theta. But when you drop the existing original negative there, these two negatives will become positive. And the positive symbol just falls there, and this would still equal 0. So basically, that double negative cancels. So it's a sine plus cosine equals 0. So that's what we have. So let me actually erase this to create some space. So we have sine plus cosine equals 0. We have sine plus cosine equals 0. And what we can do is we can interpret what this is saying. Watch. If you go a number plus a number and it equals 0, there are some choices, right? There are some possibilities. Maybe this is 0 and maybe this is 0 because 0 plus 0 equals 0. That's one option. But that doesn't work for us because on the unit circle, the point 0, 0 is right there in the middle, but it's not on the circle. We got to get something that's on the edge, on the circumference of the unit circle. So that doesn't work. The case where they're both 0 doesn't work. Or it could be something like this. This could be like 7, and this could be like -7, because you get 0. So it is possible for this to be a number, and for this one to be the same number, but opposite. Because if these are the same number, but opposites, and you add them up, you're going to get back 0. So that's how I want you to interpret this situation. Where on the unit circle? Where do you go? Or where can you go? So that if you add the y coordinate and you add the x coordinates together, you get back 0. And I don't care which one's negative. That doesn't matter at all. I just want them to be the same number, but one has to be a positive and one has to be a negative, but the same number. just one positive, one negative. And we agreed that that actually only happens, I want to say here, and I want to say there. Those two locations. They're the same number, one's positive, one negative. And if you add them, you get 0 as is required. So final answer, 3 pi over 4 and 7 pi over 4. And the more equations you do, the more you'll see that a lot of times you get final answers that are the same, but they could have come from completely different looking equations. That happens a lot, where you have equations that are way different looking, but you get like the same answers at the end of the day. That can happen. So this is just a brief, summary of what we did last time in class. I hope that helped. Let me know if you have any questions, and I'll see you guys in class next week.